Okay, students. So, I am going to discuss some extra questions with you all that is related to Unit 15 in your grade 10 science textbook, Hydrostatic Pressure. I already discussed the questions given in your textbook in the previous chapter. So, this is the first extra question, the MCQ type questions. You need to select the most suitable answer or the correct answer. You are familiar with these types of questions. The first one. Select the false statement regarding pressure. So, it is the false statement that you need to select. Force acting on a unit area is pressure. That is the definition of pressure. Force acting on a unit area. Usually for solids, we use the equation P equals F over A. So, that is correct. Then the second one, it is a vector quantity. Is it a vector quantity? Now, if you take the pressure exerted by liquids, it's exerted in all different directions. Air exerts pressure in all different directions. So, it is not a vector quantity, it is a scalar quantity. Although we might think if it is a solid, due to the weight of the object, the weight is acting downwards, but we divide weight by area. So, there when it comes to pressure, it is exerted over the area, but still it does not have a direction. Because of that, it is a scalar quantity. So, it is a vector quantity, that is incorrect. Then the third one, pressure increases with the decrease in surface area it is exerted on. That is of course correct. Because students, if we take the equation, pressure equals force over area. Now, if we consider this relationship, there from this if you look at it, pressure is directly proportional to force. So, that means when force increases, pressure will increase. But pressure is inversely proportional to area. When area increases, the pressure will decrease. Or in other words, when area decreases, pressure will increase. So, the answer here is pressure increases with the decrease in surface area it is exerted on. So, that is also correct. Then the fourth one, Pascal is the standard unit of pressure. Yes, that is also correct. From that equation, we get force in newtons, area in meter squared. So, because of that, we get the unit as Newton meter minus 2. But still, the standard unit that is equivalent to Newton meter minus 2 is Pascal. So, that is also correct. So, what is the incorrect statement or the false statement here? It is a vector quantity. Then the second one, the factor that does not affect pressure exerted by liquids. So, you all know the equation, students. We have done calculations. Pressure exerted by a liquid column, P equals H rho G. H is the height of the liquid column, rho is the density of the liquid column, and G is the gravitational acceleration. So, pressure exerted by liquids depends on all those factors: height, density, and gravitational acceleration. But gravity, you all know, it's a constant value. Height and the density of the liquid determines the pressure exerted by that liquid column. So, the factor that does not affect the pressure exerted by liquids. The depth of the liquid column, that is correct. Depth and height are the same. Density of the liquid column, that is also correct. Gravitational acceleration, correct. But the volume of the liquid does not affect the pressure. We have done an activity. We have actually discussed an activity where we use different shaped containers attached to a PVC tube. You can remember that when you fill in water, colored water, and observe the vertical height of the liquid column will be the same, and also pressure at the bottom is the same. But the amount of water inside the tubes or the containers is different. Volume of the water inside the containers is also different. But still the pressure is the same. So, that means volume of the liquid does not affect the pressure. So, this is the factor that does not affect pressure exerted by liquids. Volume of the liquid, depth of the liquid, density and gravitational acceleration, they affect the pressure exerted by a liquid. So those are the first two questions. We will move on to the next one. Here also students, you all can read the question first, you can answer them and then you can listen to the discussion. The third one, 3 different points in a liquid column is shown in the diagram. Ascending order of pressure at these 3 points is given by. Ascending order is the increasing order of pressure. So now we discuss, this is a liquid column. So if it is the liquid, the pressure depends on the height or the depth. So here it's the same liquid, so density is the same, gravity is the same. So it's only the height that is going to affect the pressure. If you look at the 3 points, now C is closest to the surface. So at point C, the pressure will be the lowest. So here if we arrange it, here if I arrange it according to height, it is C first, then we have A and then we have B. B has the highest depth. So B will have the highest pressure, C will have the lowest pressure. It has to be PC, PA and PB. So here we can see first answer PA, PB, PC. That is wrong. There it's in order of increasing, just the alphabetical order but not the proper increase in pressure. Second one PB, PA, PC. That is also not correct. Third one PC, PA, PB. PC, PA, PB. That is the correct relationship. Fourth one PB, PC, PA. That is also not correct. So here third one, this is the correct ascending order of pressure. PC, PA, PB. Then we have the next one. Atmospheric pressure at mean sea level is 76 centimeter mercury. Density of mercury is 13,600 kilogram per meter cube. Gravitational acceleration is 10 meters per second square. Atmospheric pressure in Pascal is given by. So here again we need to have the equation P equals H rho G. So if I substitute for H, it has to be 76, but we need to convert the unit. So we need to divide it by 100 so that it becomes in meters. Then density 13,600 and 10 is the gravitational acceleration. So from P equals H rho G, that is the equation we will get. So that has to be the answer. Atmospheric pressure in Pascal is given by 76 over 100 into 13,600 into 10. We'll look at the answers. Here of course 13,600 into 10 divided by 76 into 100 Pascal. So that's not correct. This one 76 divided by 100 into 13,600 into 10. That is the correct answer. Then if you look at the third one, 13,600 divided by 76 into 10 into 100, not the correct relationship. Fourth one, 13,600 into 10 into 100 divided by 76. That is also incorrect. So the correct answer is the second one. So I am sure you all were able to answer these correctly. With that students, we'll move on to the next one. Then extra question 5. This is the question 5 of the first extra question. Instrument used to measure the density of liquids. So you all are familiar with that students, based on the Archimedes principle, the hydrometer that floats in liquids. So we normally take a liquid into a glass jar, a tall one, and we put the hydrometer into it. From the stem, from the calibration in the glass tube, you can directly read the value for density. And you all know this functions based on the Archimedes principle. So if the density of the liquid is high, usually the hydrometer is pushed up. And if the density of the liquid is less, the hydrometer sinks further into the liquid. So based on that, you can read the density of the liquid directly, and usually the lower density is at the top or 0. It starts from 0 value, and as you go down the glass tube, the density increases. So that is something that you are familiar with. And also you all know, students, there are different types of hydrometers. The soil hydrometer, the metrolac, the alcohol hydrometer, hydrometer that is used to measure the density of battery acids, that is the acid hydrometer. Like that, you have learnt about different hydrometers in your previous grade as well. And in the lab, we saw the hydrometer also. So the instrument used to measure the density of liquids is hydrometer. We will look at the answers. First one, barometer. What do we use a barometer for? There are two types of barometers that you are familiar with. The Mercury Barometer and the aneroid barometer. Both of them are used to measure the pressure of atmospheric pressure. Then hydrometer is the instrument used to measure the density of liquids. Then the third one, sphygmomanometer. Why do we use a sphygmomanometer? To measure the blood pressure of a person. So normally you all know, when you visit the doctor, if the doctor has wants to check your pressure, the blood pressure, then they use a sphygmomanometer. There are two types of sphygmomanometers, the one that has mercury inside it, the manual one, and also the digital one. So the sphygmomanometer is used to measure the blood pressure of a person. Then the fourth one is densitometer. Now when we say densitometer, it is not related to density of liquids, it is actually related to optical density, to measure the intensity of darkness. So densitometers are used to measure the optical density. So out of all these four, hydrometer is the instrument used to measure the density of liquids. So it is hydrometers. Then the sixth question. Figure given below shows an inflated balloon attached to a U-tube containing water. So this is the figure given to you. You can see the U-tube there, and inside that there is water. This is arm A and arm B. Those are marked there. And here you can see the balloon attached to it. So you are familiar with this particular activity. We have done this in the lab also. When you inflate the balloon, air is compressed inside it. And when there is air that is compressed, it tries to expand. So when it tries to expand, it exerts a pressure. Air actually, or gases exert pressure in two ways. One is due to its weight, the other one when it is compressed. So here the compressed air exerts a pressure on this surface, the water surface at point A. Due to that, the water level is pushed down here and pushed upwards in arm B. But if you take arm B, at this surface, what is labeled as X is the atmospheric pressure. And thereafter you can see there is a water column, height is H. So that water column also exerts a pressure that you know is equal to H rho G or HdG. It can be even taken as H rho G or HdG depending on the letters or symbols that we use for density. So here the pressure at point A is equal to pressure at this point in arm B. So that is how we identify or calculate the pressure of air inside this balloon. Atmospheric pressure plus this pressure. So those are the things that you already know. When we did the activity, we discussed all these. If we look at the question, density of water is D. So here, as I told you, density is given the letter D and gravitational acceleration is G. Pressure on the surface of water in arm A is given by. So the pressure here is arm A, and the pressure is equal to the point here, and that, as I told you, is equal to X plus HdG. That will be the pressure at this point and this point. We discussed a question given in your textbook where we where we actually explain that the pressure exerted by the air inside the balloon is greater than the pressure of the atmosphere. The atmospheric pressure is less than the pressure exerted by the air inside the balloon. That was a relationship that we tried to explain in one of your questions. So, if we look at the answers, HdG. HdG is the pressure exerted by this water column only. X in HdG, there is no equation like that related to pressure here. We don't multiply HdG by the atmospheric pressure. Then the third one, X plus HdG, that is correct. Atmospheric pressure plus the pressure exerted by the water column. And the fourth one, Hd over G, that is also not relevant here. So, the answer is the third one, X plus HdG. That is the pressure exerted by the air inside the balloon. That is on the surface of water in arm A, point A. So, I am sure you were able to answer these two questions correctly, students. So, with that, I will move on to the next one. So, question number 7. Unit used to measure pressure. You all know, students, there are two common units that we always use. One is Newton meter minus 2, that is for pressure exerted by solids when we use the equation P equals force over, that is pressure equals force over area. From that we get the unit Newton meter minus 2. So that is one unit that you can remember, students. We use the equation P equals F over A. So here Newton and this is meter squared. So from that we get the unit as Newton meter minus 2. But that is equal to Pascal. And Pascal is the standard unit of pressure. So you are familiar with this. Now let's look at the answers. Unit used to measure pressure. First one, Newton meters. You are familiar with that unit also. We use that for moment of force. You can remember moment of force. Moment of force. Force into perpendicular distance from the point of application of force to the axis of rotation. So, Newton meters. Then meters per second. Where do we use that? That is for speed and velocity. Speed, velocity, we use meters per second. Then meters per second squared. Acceleration. Acceleration, deceleration, acceleration. And then the last one, Newton meter minus 2. So that is pressure. So unit used to measure pressure is Newton meter minus 2. So that's the correct answer. Then the next question. Diagram of a hydraulic press is given below. So here you can see a diagram of a hydraulic press. So you know what a hydraulic press is, students, and an instrument or machine used to lift objects. Very heavy objects can be lifted by applying a small pressure. How is that possible? Because pressure exerted to one end. Now here you can see this is one arm. There is a piston connected to it, and you can see from the diagram a force of F1 is applied there. Surface area is shown A1. So when you apply a force here, there is a pressure exerted onto the liquid, and that pressure is transmitted through the liquid. And that again exerts a pressure here, but that pressure is equal to force over cross-sectional area there. So when you have two arms, one arm small and the other arm large, or one small piston and one large piston. By applying a small force to the small piston, we are able to lift another larger force on the larger piston. So that is the concept of hydraulic press. So that is the diagram shown to us. Area of the small piston is A1. So that is shown here. Area is A1. Area of the large piston is A2. That is also given there. Force exerted on the small piston is F1, another value. And correct relationship for the force acting on the large piston is given by. So that is what we need to find. Here, of course, students, you all know the relationship. Pressure on this side, that is given by F1 over A1, that is equal to F2 over A2. By the same liquid and at the same levels, the pressures are the same. Same level of the liquid, the pressure is the same. So, because of that, F1 over A1 is equal to F2 over A2. So, we need to find the relationship for the force acting on the large piston, that is F2. So, if you rearrange F1 into A2 over A1 will give you F2. So, that is what we need to find. This should be our answer. That should be the answer. So, if we look at the answers given there, F1 into A1 over A2, that is not correct. F1 into A2 over A1, that is same as this. This should be the answer. So, here you can see F1 into A2 over A1, that's correct. F1 over A1 into A2, that is also not correct. A1 into A2 divided by F1, that is also not correct. So, the correct answer is F1 into A2 divided by A1. That is the correct relationship for the force acting on the large piston. So, with that, students, we will move on to the next one. 9th question. The weight of a box of eggs placed on a table is 50 Newton. The area of the base of the box is 0.1 meter squared. The pressure exerted by the box on the table. So, this is very easy. The direct equation where we use pressure equals force over area. So, force is given to us as 50 Newton. So, here you can see the area is given as 0.1 meter square. So, that is what we need to write here, 0.1 meter square. So, if you calculate the pressure, 50 divided by 0.1, we will get the answer as 500 Newton meter minus 2, that will be equal to Pascal. So, if we look at the answers, it has to be equal to 500 Pascal, the first answer. 500 Pascal, not 5000 Pascal, 50,000 Pascal or 2500 Pascal. It has to be 500 Pascal. So, that's the correct one. Then the 10th question. The height of the mercury column at mean sea level is shown in figure A is 76 centimeters. So, here is figure A. You know this is the Mercury Barometer. So, this is the mercury column and that height is 76 centimeters. Always, students, we need to take the height difference between this surface and this surface. Whether you push the glass tube down or whether it's lifted slightly above here, it doesn't matter. The height is from this point to this point. That is marked as 76 centimeters. Then there is another figure, figure B also shown, where the tube is inclined. It is at a slant position, inclined position. So, still here you can see there is a height marked as h. Let's look at the question. The glass tube gets inclined as shown in figure B. So, we saw that as well. What is the vertical height of mercury column in figure B? So, vertical height is marked as h. Now, here in this column, of course, students, there are two heights or two length we can say. There is this, I'll mark it as L and this is h. So, obviously, you all know L is more than h. But what is the value we take for calculations? We always take the vertical height. Why is that? Pressure exerted by a liquid column depends only on the vertical height, not the shape of the container or the volume of the container. So, here, if we consider this the shape, it's something inclined, but the vertical height is this. So, if both of these figures, both of these barometers are kept at the same place, this vertical height has to be equal to 76 centimeters because that is what is related to the pressure. The same liquid, density is the same, gravity is the same. So the height has to be same. Is that clear to you all? So then, vertical height of mercury column in figure B also should be 76 centimeters. Not greater than, not less. It shouldn't be less than 76 centimeters, or it should not be greater than 76 centimeters. It can't be greater than or equal to. It has to be 76 centimeters. Although this length is greater, the vertical height is the same. I am sure you all can understand that. So with that, students, we will move on to the next slide. Extra question 11. Consider the statements given below. Consider the statements given below. A. Weight of an object that floats completely immersed in water is equal to the upthrust exerted by water. That is correct. Weight of an object that floats completely immersed in water is equal to the upthrust exerted by water. Weight of an object that completely sinks in water is greater than the upthrust exerted by water. So, if we take two instances, in one, it is completely immersed and floating. So, upthrust is upwards, weight is downwards. Here, weight is equal to upthrust. That is where the forces acting on the object are equal. There is equilibrium and it is floating completely immersed in water or the liquid. Then the second instance, the object completely sinks. Weight of an object that completely sinks in water is greater than the upthrust exerted by water. That is correct. Why? Because here also upthrust is acting upwards, weight is downwards, but because the weight is greater than upthrust only, there is an additional force acting downwards. That is why the object is pushed down. So, object comes and rests at the bottom surface of the container. So, both these statements are correct. In the first one, weight of an object that floats completely immersed in water is equal to the upthrust exerted by water. That is correct. Then the B part, weight of an object that completely sinks in water is greater than the upthrust exerted by water. That is also correct. So, from the above statements, only A is true. Only B is true. Both A and B are true. Both A and B are false. So, the correct answer has to be both A and B are true. Both of them are true. So, then we will move on to the next one. Question number 12. So, in question number 12, vertical height of the liquid column as shown in the figure is h. So, here the figure is given to you. Vertical height of the liquid column is h and the density of the liquid is d. So, here density is d. The correct relationship for the pressure exerted by the liquid at point x of the liquid is given by. So, here they want you to find the pressure exerted at point x. So, normally what is the equation, students, for pressure? Equation is h rho g, or for that matter h dg. So, here h is h, d is the density and gravitational acceleration is g. P equals h dg. So, the correct relationship for the pressure P exerted by the liquid at point x of the liquid is given by P equals hd, not correct. P equals hd over g, that is also not correct. P equals hdg, that is the correct answer. P equals hg over d, that is also not correct. So, always the equation is P equals h rho g. If the rho density is given by d, the equation becomes P equals hdg. So, that is this answer. I am sure, students, up to now you have answered all these questions correctly. With that, we will move on to the next one. Extra question 13, MCQ type. Select the correct relationship for the pressure P of air trapped in the glass tube. Density of the liquid is D. So, if we look at the diagram, so here students, this is what we need to find. The pressure exerted by the air trapped inside the glass tube. So, that pressure will be felt at this point. So, if we draw a line there, at this point also the same pressure, here also P, at this point also P. That is the pressure exerted by the air trapped inside. Okay. So, then if you take this whole diagram, at these 2 points, here also, at these 2 points also, it's going to be the same pressure. Here also, it's going to be the same pressure. So, what is the difference? Now, we know in a liquid at the same level, pressure is the same. That's why pressure here and pressure here are the same values. These 2 points also same. At the bottom also same. So, we have the 2 heights. Now, you can see, now this height and this height, there is a height difference. So, students, if we need to take this height, how can we do that? We know the total height h2, this height is h1. So, this part is going to be h2 minus h1. Now, the pressure at this point and this point are equal. So, this pressure at this particular point, that is P, will be equal to what? The pressure exerted by the atmosphere, P1. So, then if we consider the pressure exerted by the atmosphere plus the pressure exerted by this water column, that is only this height, that is H2 minus H1. That is going to be the pressure here, and that is equal to the pressure here, the pressure exerted by the trapped air. So, P1 plus H2 minus H1 into, if it is density into gravitational acceleration. That will be the relationship. So, then if we look at the question there, select the correct relationship for the pressure of air trapped in the glass tube. Density of the liquid is D. So, H1 minus H2. No, that's wrong. It has to be H2 minus H1 into dg. So, that's wrong. HdG, that is also not correct. That is the full height where they haven't told us what H is. Then H2 minus H1 into dg. That is correct only for the pressure exerted by this particular column. But if we look at the last one, P1 plus H2 minus H1 into dg. That is the correct relationship. P1 plus H2 minus H1 into dg. So, that's the answer, correct one. You all can see it clearly, students. From the diagram, the height difference between this arm and this arm is H2 minus H1. So, pressure exerted by the atmosphere plus the pressure exerted by this part of the water column is at this point. The same pressure acts here, and that is the pressure exerted by the trapped. So, there it is the answer. Then we will look at the next question. 14. The diagram given below shows the hydrometer in different liquids. Ascending order of density of the liquids based on this observation. Ascending order of density. Density of the liquids are given by PA, PB and PC. So, we will look at the diagrams first. The first diagram A, you can see the density of the hydrometer is somewhere here. That is the density is PA. Then here we have the second diagram B, hydrometer is above. And in the third diagram, the hydrometer is right down to the bottom. So, here students, you all know the relationship. If the hydrometer sinks more, that means the density is less. If the hydrometer floats up, then the density is more. Or in other words, a lesser density liquid has to be displaced more in order to exert an upthrust equal to the weight of the hydrometer. You all know that principle, students. Now, when the hydrometer is floating in a liquid, if you have a liquid like that, this is the hydrometer. So, upthrust is equal to weight of hydrometer. Why? This is the Archimedes principle. So, an upthrust will be equal to the weight of the object when it is floating partially or fully immersed in a fluid. So, then again, this part, if this part is within the liquid, that is the volume of liquid that would have been displaced. So, if you calculate that weight of that volume of liquid, that will be equal to the upthrust. If the liquid has a higher density, less volume of liquid can be displaced, or less volume of liquid will be displaced when the upthrust equal to the weight of the hydrometer is exerted. So, here students, as you know from the Archimedes principle and the concept of hydrometer, an upthrust has to be exerted by the liquid that is equal to the weight of the hydrometer. And this is the relationship. You all can remember that. When density is less, then more volume is displaced. Why? Then only it can easily exert the upthrust equal to the weight of the hydrometer. But if density is high, then of course less volume is displaced, so that it can exert an upthrust that is equal to the weight of the hydrometer. So, when we say more volume is displaced, the hydrometer has to come down. It has to sink down further. If it is less volume needs to be displaced, the hydrometer will be pushed up, or it will float higher up in the liquid. So, that is the concept that is used in the hydrometer. That is how we measure the density of different liquids. So, if we look at the three diagrams, here you can see in diagram B, the hydrometer is very high compared to the three instances. So, the density of B will be the highest. Then we have this next one, A. A has it's sunk a little bit more compared to B. And in C, the hydrometer is right almost towards the bottom of the container. So, that means C has the lowest density, B has the highest density, and A has a density in between those two values. So, here of course we need to find the ascending order of density of the liquids based on this observation, and the densities are given by PA, PB and PC. So, if we look at the answers, PA, PB, PC, that is not the correct answer. PB, PA, PC, that is also not correct. PC, PA, PB, that of course is correct. This answer is correct. PC, PA, PB. PC, PB, PA, that is also not correct. So, the third answer gives you the correct order, ascending order of density of the liquids based on this observation. So, I am sure you all have a good understanding of the function of a hydrometer, how it is related to the Archimedes principle. With that, students, we will move on to the next slide. Extra question 15. Weight of an object in air is 15 Newton. The weight observed when the object is completely immersed in a liquid is 3 Newton. The upthrust exerted by the liquid on the object is equal to. So, this is something that you are very familiar with, students. So here, when the object is in air, it shows a reading of 15 Newton. But then when it is immersed in a liquid, the object is completely immersed in a liquid. So here students, when it is completely immersed in a liquid, the weight is read as 3 Newton. So from this, what can you understand? Although we immerse it completely, but we are still holding it to the, still it is attached to the Newton balance. So that is why you get a reading. Normally you all know students, if the object is either fully or partially immersed in a liquid and is floating, the weight has to be equal to the upthrust. So then you will not get an apparent weight. You all know that. So normally the apparent weight will be 0. But here there is an apparent weight. That means the weight is greater than the upthrust. So if you just allow that, if you just put this object into water, it will obviously go and sink in water, because there is a force acting downwards. I am sure you all can remember that. So then, based on this observation, if we are to calculate the upthrust is equal to what? Upthrust equals weight loss. So what is the weight loss there? Initially it was 15 Newton minus 3 Newton. That is 12 Newton. So the upthrust exerted here is 12 Newton. So from the calculation also you all can understand. Weight is more, upthrust is less. So then the object will sink. So here the upthrust exerted by the liquid on the object is equal to 12 Newton. That is the correct answer. Is that clear to you all students? If an object is completely or fully immersed in a liquid and is floating on its own, obviously the weight has to be equal to the upthrust. If the weight is more, then the object will sink. Why? The downward force is greater than the upward force. So there is a resultant force acting downwards which will pull the object down. The object will sink in the liquid. And you all know, if the upthrust is more, then what happens? The object is pushed upwards so that it will make the upthrust equal to the weight of the object. So that is why the object goes above the liquid surface. Okay, so then that is the answer for this question. Then the next one. 16. False statement regarding pressure exerted by liquids. The false statement. So always you have to check this, whether it's a true statement or the false statement. False statement. Liquids exert pressure in all directions. That is correct. We have observed this also. Pressure decreases with the decrease in the depth of the liquid. That is also correct. Normally pressure increases when the depth increases. So pressure decreases with the decrease in depth of the liquid. That is correct. Pressure exerted by a liquid is the same at a particular level. That is also correct. These are the characteristics of pressure exerted by liquids. Then the fourth one, pressure increases with the decrease in the depth of the liquid. That of course is wrong. Pressure increases with the increase in depth. So this is different from the second one. So this is the false statement. So false statement regarding pressure exerted by liquids is the fourth answer. Pressure increases with the decrease in the depth of the liquid. So those are the questions here, students. We'll move on to the next one. 17th one. Select the correct relationship between the pressure at points A and B of the liquid present within the U-tube. Points A and B. So let's look at the diagram. So here this is the U-tube. It has equal amount of water or any liquid inside it. So here you can see this height is equal to this height. and this is the same level, points A and B. So then of course pressure at point A should be equal to pressure at point B. PA should be equal to PB. Why? It is the atmospheric pressure acting at these 2 points. They are equal and this height is equal to this height. The pressure exerted by this water column or the liquid column is also equal. Or in other words, if you say the pressure at the same level of a liquid is equal. So this is the same level. So either way, if you look at the values, PA should be equal to PB. Then, if we look at the answers, select the correct relationship between the pressure at point A and point B of the liquid present within the U-tube. PA greater than PB, that's not correct. PA equals PB, that is the correct relationship. PB greater than PA, that is also not correct. None of the above relationships are correct. No, that's also not true. So it is PA equals PB. Then the next one. Question number 18. Not an application of atmospheric pressure. So you all know, students, we discussed a few applications of atmospheric pressure. Can you recall those? One thing, drinking water or any fluid from a straw, using a straw. Then the rubber sucker, the siphon method. All these use atmospheric pressure, applications of atmospheric pressure. So not an application. Here the question is not an application of atmospheric pressure. First one, drinking from a straw. That is correct. That is an application. Drawing water from a well using an electric motor. Using an electric motor, does it use atmospheric pressure? No. There it is using electricity. The motor works, it pumps water. So that does not use atmospheric pressure. Transferring water from a tank into another tank below it. Yes, that is the siphon method. So this is the siphon method. That is also correct. Then the fourth one, attaching a rubber sucker onto a glass surface. That is also an application of atmospheric pressure. So the relevant answer would be drawing water from a well using an electric motor. That is not an application of atmospheric pressure. Is that clear to you all, students? So then I will move on to the next one. So question number 19. The depth of a pond at a certain point is 3 meters. Pressure exerted by the water at the base of the pond. That is what they want you to calculate. So this is a question where we have done similar calculations. Normally when it is a pond or a water body, pressure is given by H rho G. So here they have given the H as 3 meters. What is rho or density of water? They have given as 1000. It is 1000. And I will substitute with the units kilogram meter minus 3. And also gravitational acceleration 10 meters per second square. So we will get the answer as 30,000 Pascal. When it is in meters, kilogram meter minus 3 and meters per second square, you get the direct unit as Pascals. So the depth of the pond at a certain point is 3 meters. Pressure exerted by the water at the base of the pond. That is what we need to find. 30 Pascal, no. 300 Pascal, no. 3000 Pascal, that is also not correct. 30,000 Pascal, that is the correct answer. Then the last MCQ, 20. An object with a mass of 10 kilogram floats completely submerged in water. So when they say floats completely submerged in water, the mass is given as 10 kilogram. So if we want to find the weight, what do we need to do? Always when it is flotation, it's the weight that we need to consider. So weight is mass into gravitational acceleration. So gravitational acceleration has to be 10 meters per second squared. Meter second minus 2. So, here G has to be 10 meters per second squared. Then, of course, it floats completely submerged in water like shown in the diagram. What is the upthrust exerted by water? So, in this instance, students, what happens? The weight is down, upthrust is up. When an object is floating, always upthrust is equal to weight. So, that is equal to weight has to be 10 into 10. 10 is the mass, kilogram is mass. You all know the relationship, students. Weight is equal to mass into gravitational acceleration. So, 10 kilogram mass, gravitational acceleration 10. So, that is going to be 100 Newton. So, that is the upthrust acting on the object. So, here, what is the upthrust exerted by water? 10 Newton, 100 Newton, 1 Newton, no any correct answer. No, we do have the answer 100 Newton. So, that is the correct answer. So, students, now this is the last MCQ question under extra question 1. I am sure you were also able to answer all these questions correctly. And with that, I will end this chapter, and in the next chapter, I will discuss more extra questions where you need to write the answers.